Okay, so what we have here now is a long bolt from that I bought from a hardware store again, and these wires are also available at any hardware store, and you can ask for a 14 gauge. This is a 14 gauge wire, thinner wire than a 12 gauge, and that it is wound with so many turns, tightly wound on this bolt. So as I said before in the previous video clip, that the passage of current through these wires induces induces a magnetic field that is conveyed, or that is being augmented rather, by this bolt. So this bolt does not have any current in it. It has a magnetic field, and that is what it uses, or that can be observed rather, when these paper clips will be attracted. So currently, as you can see, it is not magnetized, so there is no magnetic field, and these iron paper clips or steel, remember it's not stainless steel, it is just regular steel with some coating, and these are not attracted. So now what I'm going to do is then connect the battery, and we should see the difference. As you can see, quite a few of these paper clips are attracted, thus providing an evidence that the magnetic field is indeed generated. So the magnetic field so generated depends on primarily on two factors. One being the amount of current, and as you can see there is some residual magnetism, but now it's no longer there. So it depends on the amount of current passing through these coils and the number of turns wound on this bolt here. So greater the number of turns, the greater the magnetic field, or stronger the magnetic field produced. And to illustrate that, I'm going to take another bolt with fewer windings and show that with the same amount of electric current available to us, this bolt will not be able to pick up or attract any of this or any paper clip. So let's see that firsthand. As you can see, the magnetic field is there, of course, but it's pretty weak. It's not so strong to be able to lift any of these paper clips. So as you can see, the number of turns, or the number of windings, or number of times the copper wire is wound on this bolt also affects the strength of the magnetic field so generated. Now what I'm going to do then is, to show the influence of current, I'm going to keep the same number of turns but just use 1.5 volt instead of 4.5 that I used previously. Okay, so it's connected, and let's try to pick up. So it does pick up, but not as many. Previously it could pick up 2 at a time. Now it can barely pick up 1. It does attract 2, so to speak, but it's not so strong to be able to lift 2 at a time. So that indicates the amount of current passing through also makes a difference. So just to kind of recap, or rather reproduce the same result as before. Ah, the circuit wasn't proper, and now you can see it is strong enough to pick up multiples. Don't know what you can see, but as you can see, I can see here there are two paper clips attracted. I could pick up probably three if I did it a little smartly, but nevertheless it definitely shows that there is a stronger magnetic field generated due to greater amount of current for the same number of turns in this electromagnet.